Not now. Alright, let me check if the audio is working. Hello, hello, hello. Okay, how do you check this? Let me go on YouTube. My phone. Yeah, I'll start Leetcoding soon. Just wait. Oh, it's working. Alright. I'm gonna throw this up on LinkedIn as well. What should I post on LinkedIn? Haven't done Leetcode seriously in years. Seriously in years, properly in like 1 or 2 years. Come check out my live stream. Where is this? In years, properly. Okay. Host properly in like 1 or 2 years, guys. All right. Come check as always, do top interview questions. Stream. I'm starting with the easy set just to get practice in. Where is this? Let's see. First question. Yeah, I might be embarrassing myself here. Years, just properly. Okay. Host. I'm gonna 1 or 2 guys. These questions. All right. Come check as always, do top interview questions. Stream. All right, there we go. So live streaming. All right. What do you want to do in this question? Give an array, remove in place unique elements, relative order element to the same. Sorted in decreasing order. Okay. So let's look at the example. So always before you even start coding, like write out your solution, because like you're gonna mess up in coding quite a bit. So if you write it out, at least the interviewer knows like, oh, this guy knows what he's doing. It's probably like some dumb issue. Wonder if I'm getting any messages. I don't really know how to check messages on that, but it's fine. Let's see. So this is probably like a left pointer, right pointer approach. So left tells you the last valid index, and right tells you index you're looking at. And then you just gotta update left. So you can do this in O of n, and then these values, we don't care what they are. So let's start coding this. Let me make sure you guys can see the code. Okay, there we go. And you want to return the count, which is just left. So int left is equal to 0, right is equal to 0, for int I is equal to 0. We just call this right here. Alright, this is the nums.length. Plus. Okay, so if nums at right, so start this at 1, is not equal to nums at left, because this is sorted already, then nums at left plus 1 is equal to nums. And let's start left at -1. Actually, we can start this. Yeah, that's fine. Nums at left plus 1 is equal to, is equal to nums at right. Plus. Okay, so we start right at 1 because we know the first one's always going to be valid. And then we want to just return left. So you run that code. Hope you guys see that. Okay, so it finished running. Let me like zoom up. Submit. Wrong answer. 0, 1, 2, 2. Okay, so I'm at left plus equals 1. Nums at left equal to nums at right. Dang, Oregon cooked. So that's why you should practice Leetcode. Last valid index. So let's see what I'm doing wrong here. So we have left and right. Let's start left at -1 and right at 0. Or left at 0 and right at 0. And let's think about this very slowly. So if nums at right is equal to nums at left, we want to increase right. Otherwise, if it's not equal, what we want to do is we want to set nums at left equal to nums at left. We want to increment left first of all, so left plus plus. And nums at left now is equal to nums at right. And right will increment automatically. Run code. And I guess in the end we want to return left plus 1. Yeah, because it's 0 indexed. Now we can submit this. Wrong answer again. Again, let's see if nums at right is equal to nums at left, right plus plus. Else left plus plus, nums at left is equal to nums at right. So what is the input here? 1, 2. Yeah, I'm embarrassing myself, but you know, that's okay sometimes. Nums at right, which is 0, is equal to nums at left, right plus plus. But then we do right plus plus again. So this is the mistake right here. Duh. Alright, accepted. So this is why you should really step through the code, not what I did. What I did was I kind of jumped into it too fast, which is okay. It happens. Let's open this question up in a different tab because it's so hard to read. Best time to buy and sell stock. Which one is it? It's number 2. Alright, here we go. There we go, that's a lot better. Well, that's a medium question. Why is it in the easy playlist? Okay, buy and sell stock. Buy on day 2, sell on day 3. So this one, we're not going to jump into coding right away. We're going to step through it. Let's see, 7-1. Buy on day 2, sell on day 3. So you buy on day 7 automatically, because what if the next one's like 1,000, right? But then you see 1 and you want to buy on 1 instead. So even though we technically bought, we could just pretend that we didn't. So if the current value is less than, let's call this I and J. So let's say B and I. So B is the value buy at, and I is the current index. Okay, so if number at I is less than the value you buy at, then update your buy at. If it's greater, then you want to sell. Okay, but what if you have something like 1, 2, 3, 4? So you want to buy at 1, sell at 2, but then you want to buy at 2 again. So whenever you sell, you want to also update your buy at to be the current value, because that way you can account for increasing sums. So say it's 1, 2, 3. You can say 1, sell at 2, but instead keep that profit, now sell at 3 again, because you can do 1 to 3 automatically as well. So buy at 1, sell at 3. It's kind of a hacky way to get around it, but if it works, it works. Like there's no restrictions on like, hey, once you buy, you know, you only have this many buys left, your buy count decreases. So you gotta think about the restraints in the problem. So int buy index is equal to 0 and int profit is equal to 0. We want to return max profit. I is equal to 0. I prices length I plus plus. Okay. So now we have our two conditions. If not prices I is less than prices at buy end. Else if she's just else. Update buy price. You don't even need index. You just do buy price. Buy price. Buy price is equal to prices at I. Otherwise, update profit plus buy again. So profit plus equals buy price at I. So buy price minus the current price we're at. Buy price and profit. No, buy price is not equal to the current price we're at. Prices I. A lot of you might be thinking, why am I using Java? I just like Java. I've always used Java for interviews. Honestly though, C++ is better. Python's way faster. TypeScript's even better. I just don't like switching it up too much. Except if it's like, if you need to make an API call, I'm not using Java. Java sucks at reading input from anything. You know, buffer in, buffer out is kind of a pain. But let's step through this problem step by step with our conditions. So we buy at 7. So it's actually what I do for a lot of my videos. You buy at 7. Current index is 0. Then you go to 1. And let's call profit equals 0. You go at 1, so you want to update your buy price. Now you go to index 2. So index 2, let's call it I2. 5 minus 1 is 4, so you can update the buy price to 4, have a profit of 4. Buy price to the current price, which is 5, have a profit of 5 minus 1. 5 minus 1, which is equal to 4. I3, just update the buy price. I4, index 4, it's 6, so 3 minus 6, or my mistake, 6 minus 3. 6 minus 3 is equal to 3 plus index 5 is 4, and that's a lower value. We just update the buy price, so our total is a profit of 7. That's what they get too. Let's just submit it. Turn profit. Yeah, you see something like max profit and you're thinking, oh, I gotta do some dynamic programming. It doesn't always have to be that complicated, you know? What are we messing up? If prices otherwise minus buy price, price equal to prices I. Buy price is equal to prices at 0. It's not 0, so we're making a 7 profit right away, and we start from index 1. Pretty good. Next problem in our list, rotate array. Resume. Okay. Alright, one second, I just upload something. See if I can open the stream here. See messages. Oh, Omar says hi. What's good, G? That's nice. Okay. Oh, dude, what the hell? This is an easy playlist, but they have medium questions in here. This is ridiculous. Yeah, we can just submit it here. So it shows a little check mark. But yeah, that's ridiculous. Rotate array. Okay, I actually do remember this problem. Like some problems, you kind of like, they stick with you, right? This one I did a long time ago. So basically, how would you do this normally? Normally, you just make an auxiliary array and start with, hey, let's just start from the 4th index, 4, 5, 6, 7, 8, 9, or wherever it is. So you shift it by 3, go 3 back to see your start index and go loop through the array. But they want to do this in place, so that's no extra memory. So I honestly don't think this is a good Leetcode problem, because it kind of just says, hey, are you able to like have good visualization skills? Like, most people, I wouldn't say, would not get this problem. So, because how are you supposed to determine that this is a double reverse? So first reverse, you get something like 7, 6, 5, 4, 3, 2, 1. Second reverse, you want to reverse like, what was it? So, wait, 1, 2, 3, 4, 5, 6, 7, 7, 6, 5, 4, 3, 2, 1. How'd it go? No, that wasn't it. There was 2 reverses you had to do. Let's see how it ends up. So I guess this is the second reverse you have to do. So then you have to reverse the first half. So 0 to k minus 1, 0 to k minus 1, and then k to length. That's what it is. So yeah, nobody's really like thinking about this, because like, unless you know this question, you know it. Maybe some like quant are like, oh, a double reverse, so obvious. That's not obvious for normal people. But yeah, that's basically the array. I mean, the best way I would get to the solution is like just doing enough, like examples, going through enough examples and trying to find that pattern, but pretty hard. And let's do oh yeah, Java is passed by value. Like, this is why I like C++ better, because it's more well defined than Java. Like, you never really think about pointers when you're using Java, because the concept doesn't really exist. It's like under the hood. So it's like more abstracted than C++, or yeah, C++. But what do we want to do? We want to do intemp is equal to nums right is equal to nums left to the nums right, or temp. Here we want to do right minus left plus. That's a whole reverse function. So again, reverse array nums 0 to nums dot length. Let's pull out that value. Reverse array nums, what's our second one? 0 to k minus 1. And then reverse array nums 0 k to length minus 1. This should be minus 1, because we're not accessing that last value, right? It goes from 0 indexed, so first value is 0, last index is length minus 1. I'm pretty confident about this. Let's just submit it. Ah, shoot. Yeah, that's why I like Kotlin better. So if you guys don't know what Kotlin is, it's basically TypeScript for Java. Index out of bounds for length 1, while left is less than right. Index 1 out of bounds for length 1. Yeah, length minus 1. What the hell is the problem there? Oh, okay. Is equal to int new k is equal to k mod length. Yeah, this is a caveat. If you're reversing like 0, 1, 2, 3, 4, 5, 6, 7, 7, it like gets reset to normal. If you're like pushing everything down 7 indices, it ends up as original place. So you just want to mod the length. and use new k instead of k. There we go. All right, 3 problems done. Yeah, it's a long time since I've done these problems. Like, I still have some remnants in my mind, but as you can see with that first problem, it's not always so clear how to do these problems. Like, I can't remember them that well. Let's submit that. Alright. Continuing on to contains duplicate. Okay, this is like brain dead problem. Like, it's like asking you, hey, do you know what a hash map is or a hash set is? So we don't have to talk through this at all. And this is simply for int a in nums if scene dot contains a, return false, otherwise scene dot add a and return true. Yeah, I know my formatting is really ugly, but who cares? Just say easy problem. If it contains a duplicate, you want to return true, so return false here. Okay. Okay, yeah, brain dead solution. Okay, single number. I got a call at 2, so I'm gonna try and finish as much as I can until then. Okay, this is another dumb problem. And you're gonna remember, how do you remember this problem? It's because I was doing Leetcode question of the day for, I think it was May 2021 or 2022. And I was like, oh man, what's the cleanest solution for this problem? And you wouldn't believe it, it's exclusive OR. So exclusive OR is like a bitwise operation. And if you know what it is, you kind of can figure it out why it works so well. So exclusive OR. That means you take one if one or the other are 1, but not both. So if you have like, let's see the bitwise representation for like 7. 7 is in 4 bits, it would be like 0, 1, 1, 1. So 1 plus 2 plus 4, that's 7. So XOR with 0, what do you see? You see 7 XOR 0, just because of the properties of XOR and how it works, is 0, 1, 1, 1, because it has to be only one of them contains a 1. So 7 XOR 0 is 7. Yeah. And the second property that you need to know is 7 XOR 7 is going to be 0. So I think this is actually pretty cool to know. Like, you should know bitwise operations. People say like, oh, I'm not going to need it, but if you don't know how things work, like bottom up, it's kind of like you're just floating through the wind, just trying to listen to everybody and believe them. But you see, both of these values are 1, so they cancel out, and you get this as your result. Now, we have 2 properties. 7 XOR 0 is 7, and 7 XOR itself is 1. And we know that all numbers in this appear twice. And with bitwise operations, especially or specifically XOR, and a lot of them actually, it doesn't matter the order of operations. So you can do 7 XOR 7 XOR like 6, and it'll be the same result as like 6, 7 XOR 6, 7 XOR whatnot. So it'll be the same as 6 XOR 7 XOR 7. So it doesn't matter the order of operations that you do them in. So what you realize is you could just do XOR to every single number in the array, and the last number, so everything will cancel out because everything appears twice except the single number. And that'll be n XOR 0, which is equal to n, and that's our result. Otherwise, the more straightforward solution that almost everyone finds is let me do like a hash set and then of numbers, integers, and like every time something appears twice, boot it, and in the end you have a single number in your hash set because everything will boot each other out. But let's use XOR. Int result is equal to 0 for int a in nums. Result XOR, so the XOR equals a return result. And you can see that works. It's like, if I was an interviewer, I wouldn't expect you to get the XOR solution unless you're a low-level engineer. Like, say you're working on, low-level engineer. You're working on, like, I forget what they're called. My friends are in electrical engineering. I could probably ask them. But yeah, most people that I know that are Swedes, or most of the guys I know, they would not get this problem just because they don't really think about bitwise operations. Maybe if the interviewer told you. But yeah, that question's done. Intersection of two arrays. Okay, quickly. Given to intersection. Okay, this is actually a really easy question because the order doesn't matter. So what is this question? Intersection of arrays. A result in any order. So when you read any order, that's kind of a hint. So there's some data types that don't preserve order. So what doesn't preserve order but is fast for lookup? And that'd be something like a hash map. So we know we gotta use a hash map, and if you want to make it super simple, hash map in values of the smaller array, cross check with second array. Why? It's just that we have to store less if we look at the smaller array, but it doesn't really matter. I'll just do either or. These like further optimizations you can talk about after you're done the problem. Scene for int a in nums 1. What do you want to do? Scene.add, scene.get, or default put a scene.get or default a comma 0 plus 1. So it's just populating the array initially for a and b in nums 2. If scene dot contains, if scene dot contains b and scene dot get b is greater than 0, we want to add our result to your result array list. output, so we want to do output the add b, but we also want to decrease the value in the list. So scene dot put b scene dot get b -1. That's it. And then we can just chat we can just look this up. List or array list to integer Java. Alright, nice. Otherwise, I would just do a for loop if the interviewer was really not gonna let me do that, but usually they're pretty chill. Alright, let's run this. Let's run this. Expected 2. Oh wait, why is it just 2? Oh, okay, so if it appears twice, you only want to add it once? Oh, that's even easier. Okay, so even when it's an easy problem, guys, read it through. I feel like that's my biggest issue. Sometimes I'm just not reading through the problem. Like, that happened to me in one interview, and I solved a different problem. She's like, that's not the right one. And I was like, oh, shoot, why didn't you say anything? But it was my fault. And then, luckily, I was able to switch it around and, like, adjust my solution. I think that impressed them more, but... Oh, yeah. We can just add a. Yeah, so dumb issue. Read the problem, don't just speed through it. What are we done now? We're done this one too. Leetcode +1. Some of you might be thinking, like, how are you doing all these Leetcode problems? Don't you get tired? Yeah, so that's why I'm streaming, because I hate doing Leetcode. It's so boring. But if I'm streaming, I'm like, oh, maybe somebody's learning something from this. Whoa. Intersection of 2 arrays number 2? Oh, you gotta be tripping, bro. You gotta be tripping. I did the wrong problem. That sucks. Oh well. Okay, so this is literally the problem I did, but now it's with a hash set instead of a hash map. Oh, dude, that's freaking lame. Okay, I'm gonna go pull over my old code. So the one I accidentally did was a problem I solved for, but I should have done this problem because I just didn't read it right. Oh my god. Alright. Scene dot add a, scene dot get or default a comma 0 +1, scene dot put A, B, comma, C dot get B minus 1 contains key B and C dot get B is greater than 0. Okay, so I guess this is still good practice. Run this. It's the worst. Integer, hash, map. Submit. Dang. Alright, there we go, finally. Now let's copy over this code. So they're really similar problems. The only difference is the data structure you use to contain them. Submit. Alright. So accepted +1 now. Leetcode +1. You're given a large integer. This is so annoying. Okay, basically start at the end of the array, and if there's overflow, make a new array. So int a is equal to int, let's just do a for loop, 0, I is equal to, let's start at the end, 0, I is equal to length, minus 1, I is greater than or equal to 0, I minus minus. So this question is just adding a digit. So you gotta focus on two things. Is there carryover? So int carry is equal to 0. So if it's basically a 9 and it goes to 10, there's gonna be carryover. It's kind of like what we did when we were kids. So digits at I is equal to digits at I plus 1 mod 10 plus carry. Oh, actually, no, it's just plus carry initially. So let's say carry, we're not adding 1 to each digit, we're just adding 1. So this is the value we carry over. Digits plus carry. If digits at I is equal to 10, digits at I is equal to 0, and carry is equal to 1, and, or not 1, let's do, yeah, carry is equal to 1. Yeah, so if you have a 10 carry over, otherwise we can just break or just return digits. So we just added the 1. This one is need to carry it over. So if carry is, no, if we get to this point means we kept on carrying to a new new value, new like digit. So int array output is equal to new int array digits dot length plus 1. Output at 0 is equal to 1. So what is this? This is a case like over here. It goes from 9 to 10. So we carry over, but now we're reaching an index that doesn't exist, -1. So we just return output here. So this could also be like example of getting here. It'd be like 99, 99 to 100, or 9999 to 10,000, stuff like that. Okay, cool. Next one is move zeros. Leetcode move zeros. People ask me like, why are you doing easy questions? It's kind of pointless, isn't it? If you can't do the easy questions, you can't even do the medium ones. Also, it's just good practice, you know, get your confidence built up for doing Leetcode again. It's like working out, right? You gotta warm up. So I'll probably finish the easy playlist today and start the medium one as well. I have a call at 2 though, so that's what I gotta watch out for. Move all the zeros. Oh, okay. So you see like common patterns and problems. So there was that first problem we did. What was that? That was remove duplicates from sorted array. This problem is essentially the same idea where you want a pointer to keep the last valid index and you want to iterate through the array. So what is a valid value? Defined as something that's not 0. So we want to take a 2-pointer approach. One to like hold last valid index, and the other to iterate through the array. Through the array. Okay. Maybe I should make the font bigger. I don't know how to do that. Alright, whatever. I'll just make the screen bigger. That's good. Okay, so let's look at this example. It's nice having one right in front of you as you're coding so you can make sure you're not making any mistakes. I like to line them up. Let's see, int last valid is equal to 0 for int I is equal to 0, I is less than nums.length, I plus plus. If nums at I not equal to 0, so what is this? This is a valid value. Then nums at last valid is equal to nums at I, and move this pointer up. And then what do we want to do? We want to zero out the rest of the array. So for int I is equal to last valid, I is less than nums at length, I plus plus, nums at I is equal to 0. So this is zeroing out the rest of the array. Okay, run. Yeah, that works. Submit it. Okay, cool. Let's copy this code over. Oh, nice. So already copied over. Okay, two-sum. Wow, isn't this a throwback? So even if it's an easy problem, it's in the top interview questions playlist, I'd say do it, because you don't want to be making dumb mistakes on interviews. I feel like a lot of the times what screws me up on interviews is not understanding how to do the problem. It's like dumb coding mistakes that just kind of get you, and you're like, oh shoot. So this is like the quintessential problem that people learn first off, and they're like, oh, what's a hash set? C contains, oh, but we want to return the indexes, right? Oh shoot. Then we need hash map, integer and hash map. C contains, so what is this? This is value comma index. so key value. Scene that contains target minus nums at I. Then we want to return new int array with the two values, which are scene.get target minus nums at I and I. Okay, that's clean. Otherwise, we want to do scene.add, and we don't have to worry about like, oh, we want the two lowest, because it's exactly one solution. So there's not gonna be like 2, 2, 7, because that means there wouldn't be one solution. Yeah. Scene.get I and I. Return your int array -1, -1. So that means we haven't found anything. Okay. Index 7. Scene that contains key target minus nums at I, because we're not iterating through the indexes here. There we go. Wrong answer. -1, -1. Expected 0, 1. Target minus nums at I. Scene dot get target minus nums at I and I. Otherwise, scene dot get I. What? No, this is, you're supposed to put nums at I and I. Okay, twosome done. Valid Sudoku. Valid Sudoku. Leetcode. Yeah, I've been looking at some Leetcode, what's a LinkedIn post about some guys that made a cheating software that is undetected by Zoom and like Google Chrome and stuff. I feel like pretty soon it's gonna be back to the days of like, what's it? Do you know in university when they made you put like a mirror behind you, like a physical mirror, so you could see your whole like desktop setup? Yeah, I might get back to those days if we're not careful. Okay, so what are the 3 conditions we need to satisfy? Each row must contain 1 to 9. No dupes. Each column must contain 1 to 9. No dupes. Values in 1 to 9. No dupes. Some values in. So this is the important part. You don't need all of them because a lot of them will be. And each box must contain some values in. Should we just say mustn't contain dupe? Actually, it has to be values in 1 to 9, but no dupes. Okay, this is crazy to say, but I remember watching a Nick White video from like 4 years ago, which went over this solution. It's just like sometimes this solutions just stick in your memory. This is one of them. Most of them don't, but this one especially stuck in my memory because the way I thought about it was, let me make a hash set for each. So let me make a hash map of hash sets, and let's have a key which is the row number. So we have row number and then a set of values. And then we can make one for column and boxes. Column, boxes, column number, box number, etc. And this is a solution I initially came up with, and I expect most people would come up with this. But you can find better solutions just by changing this value from a integer to a string, because now you can do stuff like, hey, row 1, row 2, and now instead of having 3 separate hash maps, you only have to have 1, because a string, you can place anything in it and it's a consistent identifier for each of the values. So now you can also in this have call 1, call 2. So you don't have to have a separate hash map. So it's like little things like this where you think outside the box and you find a slightly better solution. Again, I don't think anyone would be mad if you made 3 hash maps because they pretty much take the same space. But, you know, it's just cool stuff like this. These could be characters. Okay. What do you want to do? You want to first go through each row and column. Sometimes I think to myself, is the job market bad? And it's pretty like competitive. I wouldn't say it's bad. But I knew some guys, they didn't have a job for like a year after graduation. And then they just got a job recently. So it's pretty bad. So let's calculate the row name is equal to just row plus R. Call name is equal to call plus C. And the box name is equal to, let's see, so 0, 1, 2, 0, 1, 2. And then the highest value, so I'm thinking of like how to define a box. So we have index 0, 1, 2, 0, 0, 1, 2, 0. Yeah, 0, 1, 2, and 0, 1, 2. So I guess x plus y at most would be equal to, no. Let's see. How do you define all the values have to be in this box? So should be a good way to do it. 2 plus 2 is 4. But then this value over here, 3 plus 0 and 4 plus 0, these aren't inside the block. So that's not a good way to do it just off of the value. Let's see. Let me think. So what if we did x divided by 3 is 0. And because 2 divided by 3 integer division, you round down, is equal to 0, or you just cut off everything after the decimal. And this will fit everything in this box. And 3, 4, 5. If you add this together, 3 plus 1 is 4 divided by 3 is 1. 4 plus 1, 5 divided by 3 is 1. 5 plus 1, 5 divided by 0, 1, 2, 3, 4, 5. 5 divided by 3, 6 divided by 3 is 2. Oh, that's not good. 1, 1, 2. No. 5 divided by 3 is still 1. My mistake. So 5 divided by 3 is 1. These values divided by 3 is 1. So this works. over here too. So these are just indexes, but 3 plus 0 divided by 3. Each value divided by 3. 1, 1, 1. And then let's check this one. 3. Both of these values are greater than 3, so it'd be 2 2's here. Okay, that probably will work. So let's do box plus row divided by 3 plus column divided by 3. Okay, now if map dot contains key row name, if map does not contain key row name, map dot put row name and new hash set. Let's do this for column name and block name. Okay, and now we could do if map get, so we know all these are defined. Contains oh, we gotta do, first off we gotta do value is in 1 to 9. If board at row column is less than 1, or board at row column is greater than 9. So this is AXI, if you know AXI. AXI values, they're just like character values for each that map to a letter. So 0 is like, I don't know what the 0 value is. Why is it giving me this is a good table. So here, 0 is actually 48 and 9 is 57. So if it's outside of this range of 1 to 9, then it's invalid. You want to return false. That contains board at row column. Then you also want to return false. That means we've seen it again. And we could just extend this comparison to the column and whatever else. Okay, and then otherwise we just want to add it. So map.get yeah, so it's a pretty lengthy code. It's kind of a pain. Yeah, okay, cool. And at the end of all this, return true if it's about Sudoku. Yeah, let me use that. What are we doing? Creating them if they don't exist, checking them if there's a duplicate, and then adding them to the appropriate maps. Run. Character, maybe it's because it's not well defined. Map.put, what's the problem with put? Oh, we should call this map. Oh, I spelled that wrong. Contains key. See, stuff like this will get you in an interview. Like if you spend 5 minutes on a typo, that's ridiculous. Oh yeah, double for loop, toss it out. what condition got it? Yeah, this is gonna be a pain if you don't have what's it? Oh, I think it might be this int. Still the wrong answer. Okay, so it's good to split out these things. Well, before we return false anywhere, let's print out the map. So let's print out. Actually, system.out.print line. Issue here. Otherwise. Probably, I mean, I'm pretty positive the issue's here. Oh my god. Okay, I'm dumb. If it's not anything, it's a period, right? So if it's outside of this range and it's not a period. Ah, dude, rookie mistake. Row column is not equal to a period, then return false. Okay. Yeah, but if I wanted to debug this, I'd probably split these up into their own cases, and that's still not working. Let's first move this out to this. Go to the period, just continue. Need to worry, and let's see, is it still broken? Yeah, still broken, no output, so it's definitely an issue with either the row column or the box. Let's just comment out the box. So we won't do this check, and we won't do this check, and we won't do this check. Okay, now let's run it. Because I think the way we're calculating the box is incorrect. Yeah, so it's the way we're calculating the box. Let's just print out what the box is. System.out.print line box is box name. Okay. So again, we're not doing that check, and we're just gonna see what the box names are. Okay, 001. And let's just print out the row and column too. So the idea is, if you're doing this type of for loops, you're going through first column, so it should be 01, 01, 04. Dude, what the hell? Oh, I get it, because we're doing a continue here. 01, 04, 01, 01, box is 1. Is box name. Okay, let me get a pencil and paper here. Actually, you guys can't see. Nobody's watching. I'll just use a pencil and paper just to, like, really map it out. So, is 5 correct? Is 3 correct? Is 7 correct? Actually, yeah, so, and let's print out the value too. So, value, because then it's easier to map onto the screen. So board RC space box 1 row column. Okay, run. Okay, 5 is in box 0, 3 is in box 0, 7 is in box 1, 6 is in box 0, 1 is in box 1, 9 is in box 1, 5 is in box 1, the next 9 is in box 0, the next 8 is, next 9 is in box 0, next 8 is in box 0, yeah, 2, 2, 6, box 2, 8, box 1. Oh, I see. So these two are being compared the same, which is not good. I wonder if this is simply like you just scale it like that. So now you won't have that issue of it being like symmetric. But let's see if that works. Because basically the idea is it's too symmetric right now. So that 0, 1, and 1, 0 are being treated the same. But oh, actually, even better. Why do that? Why don't we just add this plus space plus this? So this is box 0, 0, and it'll always correspond to that first box. 1, 0 and 0, 1. Since we're not adding it anymore, it's not being treated as the same thing. Because before we were adding the row divided by 3 and column divided by 3, so 0, 1 and 1, 0 are treated the same. Now they won't be, which is what we want. And I think, honestly, that'll just probably fix all the issues we have here. Damn, programming on the fly. I think that'll fix it. I'm not sure. What's the issue? X bracket. Yeah, let's go. Okay, so that fixed it. So now I hope you guys understand what the issue was. The issue was when we were adding them, 1, 0. So this is row 1, column 0, and row. Actually, no, this is 0, 1, and 1, 0. If you add them, they're both equal to 1. So these two boxes were getting compared against each other, and the 7s were matching. But since we added that space, now we know that 0, 0 is its own box, 1, 0 is its own box, and 0, 1 is its own box, so on and so forth. This is 0, 1, this is 1, 0. Oh, sweet, bro. This was a pain. Valid Sudoku. Okay, let's toss that solution in. Rotate image. Rotate the image. Leetcode. Let's check my phone. Whatever. Oh yeah. Yeah, okay. So if you've taken a course on matrices, see, like, it's these very niche problems that I know the solutions to, because like the other solutions I'll forget, but these ones I kind of remember just because they're so like you either know it or you don't. So I think my mind mentally just makes a note of that. Like it's such a unique solution that you have to remember it. And this was like back when I was taking matrix, so I was still in university, probably like second or third year. Matrices, multiplication, all that fun stuff. What you want to do is you want to transpose the matrix. So a transpose is if it's 0, 1. So 0, 1 trades with 1, 0. So if you transpose the matrix, you get 1, 5, and 9 will stay in the same position. And again, do you know when I was talking about like that one problem where you have to do a double reverse? It's like either you know or you don't. Or it's like very hard to figure out, and you figure out with use cases like rotate array, rotate image is the same. I guess if you know rotate array, like you kind of get a hint, but it's pretty gosh darn hard. So 7 switches with 3, 4 switches with 2, 2, and 6 switches with 8. And then what do we have here? We have 3 and we have 6. Now, how close is this to our final solution? Unbelievably close. All you have to do is now reverse each row. So you have 7, 4, 1, 8, 5, 2. Yeah, so if I know how to do a problem, I'm not going to pretend like I don't. Because like some of these problems just stick with me. So let's see, what is this one? 9, 6, 3. Alright, so let's make helper functions real quick. It's actually easy peasy now. If you know how to do it. If you don't, it's like, damn, let me find some janky solution. Let me first rotate the outside array. 1 goes to 3, 3 goes to 9, 9 goes to 7, 7 goes to 1. Now, let me figure out what other arrays I need to go on. So you go to the next index, 2 goes to 6, 6 goes to 8, 8 goes to whatever, this goes to this. And then let's go to this third index. Oh, this third index was covered by the first one. So there is a solution to this that isn't like so like elegant that I could walk you through. That'd probably be the solution I would have gotten if I hadn't had this like known. But why do that? You know, transpose. Okay, so do we want to go to the end? The solution is hell no we don't. We want to go to r length over 2 because we want to stop halfway point, because if we go to the end and we transpose, then we like kind of transpose twice. Does that make sense? What indexes do we want to transpose on? So 1, 1, no, 2, 2, swipe, 3, 3, swip. Then you want to go to 5. Oh, I see. So it's basically like an L shape. So we want to iterate in L shape. So first row from 0 index. And then our L shape will follow the second row from the first index. So we avoid re-swapping values. So index 1. How does this look like in this instance? So for int column is equal to row. Yeah, that's what it looks like. So 0 start at 0, row 1 start at 1, and only do that row, which is fine. Yeah, only do that row. So we're gonna do 1, 2, 3, 5, 6, and 9 for the values that we're gonna parse through. And I'm gonna give you guys a little tip before you start coding too much. You could just you don't have to like be fancy right away. You can just show your stuff works by telling the recruiter, hey, or the interviewer, hey, let's stop before we move forward and let's check if our transpose function goes through the right values. So let's call transpose on the matrix. Is it going through the right values? 1, 2, 3, 5, 6, 9. 1, 2, 3, 5, 6, 9. Okay, we're goated. So now that we know it's going through the right values, 1, 2, 3, 5, 6, 9, we honestly could start from row plus 1 because we don't have to go to 1, 5, and 9. So this will go to 2, 3, 6, and that's it. Let's see. Oh yeah, remove the print line. So if you want to like really show your adaptability while coding, if you want to show you're like an active thinker, right? Whoa. Now we're only going through the exact values that we actually need to transpose. Why? Because before we're going 1, 2, 3, 5, 6, 9, 1, 5, and 9 never change. So when row is equal to column, we don't have to do anything. So now our transpose function is optimal, which we want. Int temp to go to 0. Like doing stuff like this, like breaking it down, really showing your understanding, will impress your interviewer a lot. He'll be like, whoa, this guy's better than me. Probably not, but you know. You want to reverse array. So this is our whole code. Very clean, very clean. See, public void reverse. Alright, let's run this. Index 3 out of bounds for length 3. What am I messing up in my simple sorting function? The right index is r.length minus 1. Okay, rotate image is done. We are done. The array's set. Okay, I got like an hour and 20 minutes until I gotta take some call. Can't miss that one again, you know. Submits. Not bad. We got 3, 6, 7, 8, 9, 10, 11 questions done. Yep. Let's speed through some problems. Okay, let's see if we can get the strings playlist done as well. So I think we have enough time. String. So reverse string. Yeah, okay. Alright. Modifying the array in place. Yeah, sure. This is literally just reverse. A string, and we had to implement this a lot for all of our other functions, so this is just like the way things go. Shouldn't be too hard. Yeah, this A doesn't matter. I just threw that in there. Okay, now let's do reverse integer. What is this one? I forget. I haven't done this in a while. Yeah, that's a pain. I don't want to do this. Reverse integer. I guess you could convert it to string, reverse it, try and cast it as a integer, and if it is an overflow, throw an exception, and you could return 0. So what did I just say? Because I don't speak the most clearly. That's why I made a YouTube channel. My dad was like, you need to make some more videos. Speak clearly. So what? First, convert to string. Second, reverse the string. Third, try cast to integer. Overflow, exception, return 0. No exception, return number. I should just pull up our reverse string code. Char reverse string x string string valid is equal to valid x is equal to, or just call it new x string x string. Let's print that out. Exception. Return 0. Return. Try returning. String. 1 sec. Okay, I'm back. I was helping my brother. Something dumb. Let's check on YouTube. Leetcode. Oh yeah, it's live. Okay, I'm back. I was helping my brother. Whoa. Something dumb. Maybe. Let's check on YouTube. Okay. Enough Googling myself. Let's get back to coding. Return string to integer. Parse int. Oh, dude, why is it lagging? Okay, wait, no, that's good. Parse int. Run. I don't know, is it error? Oh my gosh, try catch Java. The exception goes before the E, not after. We're not doing Kotlin. Oh, this flips me up having to code in different languages. String cannot be dereferenced. Can I do this? Oh yeah. So toString does not exist on X, which is like a primitive. But it does exist on integer. Integer has function .toString. Oh my god. Parse int? Can I find parse int? Bruh. String to integer Java function. Bruh. Integer.parseInt. Oh, of course. It's on the integer class. Why would it be on the string class? Bruh. That's interesting. Why didn't reverse string work? Yeah, what the heck? Why didn't that work? Yo, this is like when you look at a recruiter and you're like, yo, you get this? It's ridiculous, bro. Alright, fine. Let's return a string here. Let's say return new string S. Because we've manipulated S here. So now we can debug this method. Yeah, I still asking out the wrong thing, but .out.print switching values. Yeah, it should switch values 1 and 3. Why isn't it switching it though? Yeah, this is ridiculous, man. Three, two, one. String S. Yo, the array's changed. What are you talking about, man? It says right here 3, 2, 1. But I guess yo, what the hell? This is weird, man. I guess this is extremely weird because we are changing the memory addresses, but when we call new string S, for some reason it's still using the old value. So this is actually one thing with Java I've never accounted for. This is cool. It's kind of cool because you're like, what is going on? This is interesting. Yeah, S is 3, 2, 1. Okay, maybe we just have to return. No, what the heck? So reverse string XR was new X. Oh, dude, I'm logging the wrong thing. What the heck? Okay, yeah. So it wasn't some crazy trick on Java. I was just logging the wrong thing. No. Yeah, so that's chill. And I was using the wrong value here too. So you know, it happens to everybody, guys. It happens to everybody. Get some better variable names than in UX. Actually, that's a good one. And also, if it's negative, don't convert it to a string. S dot substring 1. So if x is greater than 0, let's call string x string equal to empty boolean is positive 0. Let's just make it int. X is greater than 0, then yeah, we can just do this. Otherwise, we have x string equal to string x dot substring at 1. So remove negative, and then also we want is positive equal to -1. Yeah, this is ugly code. Ugly code. Okay, string. Oh, dude, let me get my ringer on. Let's go. All right. All right. See what we got. See what we got. Hey, that's what I'm talking about. That's what I'm talking about. Pop smoke. Hey, off the wrist, bro. Off the wrist. Okay, runtime, does it really matter? Nobody really cares. Damn. This person had it clean though. He put in a long, and because a long can store more data than an int, he just checked is it greater, less than min value, greater than max value. Otherwise, just cast it as an int at the end. And what this is just going through and just pulling off each digit, and then adding it to the number. So you're just starting from the back. So if it's 4, 3, 2, 1, add 1, then multiply by 10 and add 2. So 4, 3, 2, 1, add 2, then 3, then 4. Yeah. And then you got to divide by 10 to, I guess, ignore the extra 0. Oh, no, you divide by 10 so that you're looking at the new digit. So if it's 4, 3, 2, 1, you look at 1, divide by 10, now you're looking at 2, divide by 10, now you're looking at 3, divide by 10, now you're looking at 4, and then it's 0, and you can go out. That's a very clean solution. My solution, honestly, not that clean now that I think about it, but it's okay. It's okay because it works. And some code person's going to look at this and be like, hey, man, decent. It's decent at least. Honestly, you don't need the perfect solution unless you want to work at like a really annoying company. Because if any company says, oh, it's not the most optimal, be like, bro, I'm not working for you guys. Like, if it's good enough, it's good enough, okay? Like, if you want to work at a quant firm, you'd probably want to find a solution like they did. But if you're just looking for a solution, yo, it's all good. Okay, first unique character in a string. Dude, this is too easy, bro. Too easy. Yeah, you see a lot of repetition with common ideas. So this is an idea of finding the first repeating character. What do you want? You just want a hash set, and as soon as you find a duplicate, return the index. So for char c and s.2 char array, what do we want to do? We want to have a hash set of characters. But if you do these problems enough, you'll drill down the idea of using hash sets and hash maps, which is pretty common in a lot of problems. So scene.add c, actually, if scene.contains c, return the index. So we should probably do this by index. Pop. Now, do you want to return find the first non-repeating character? Oh, dude, I'm tripping. I thought we were finding the first repeating character and returning the index. We're finding the first non-repeating character. So let's just do a hash map of characters and integers and do a double pass. First pass, we do a count. Second pass, we do a index check. So we should have one hash map that has this should have a count. No, that should have a character and a count. Oh, do you know what? I'm gonna get fancy on you guys. Character. Just actually, it could be 3. Yeah, okay. Never mind. Hash map. I'm not getting fancy. And a second hash set for a quick lookup of where that character's index is, because we want to find the lowest one. I guess that should be a map as well, right? If scene.contains, okay, actually we just gotta do scene.put car I scene dot get or default. Oh, 1 sec, I'm doing a video.
Okay.
I'm doing a video. Okay. Just Vassy Leetcode. Up a job me family do. Hijab family. Alright, that was just my mom. Alright, scene.put, just add it all to the array. And then every time you see one, so if index lookup dot contains key car at I, so if it doesn't contain it, then just add it. Index lookup dot put car at I and I. Okay, now we just have to find first unique index is equal to 0 is equal to -1. Yeah. Now go through this for int key in scene.keyset. Go through all the keys that you have. And if scene.get key dot size, I think size is the correct thing for hash set dot size Java. Yeah, okay, is the size function is equal to 1. If it's equal to 1, that means there's one occurrence. You want to do first unique, and if first unique index is double equal to -1, then first index is equal to index lookup dot get key, and the key is just a value. Otherwise, else first unique index is equal to math.min first unique index and index lookup dot get key. Okay, why don't we just have this line? It's because -1 would be lower than any value we see. Oh my god, what a mouthful. I should have better variable names, but it's usually something I'm bad at. Whoa. Okay, run through the code real quick. First step, just add everything to a map. So you can see how many values there are, and you can quickly look up at index based on its value. The lowest index based on its value, because we're going to go 0 to the length. Now go through the keys and look at all the values that have a size of 1. That means they occur once in the string. Then update our output value, which is first unique index, and return. Run. Oh my god. Yeah, I always like those videos of people playing like Fortnite or whatever, and then as soon as they get like oh my god, as soon as they get like a battle royale finish, they got like a whole rave set up. Oh dude, what the hell? It's just like after they get in. Oh dude, I think Leetcode's blocking me because I'm just doing too many questions. I'm just that guy. Damn, this is actually crazy. Yeah. Okay, stream's over then. I can't do any more Leetcode until I guess my IP cools down and they allow me. Yeah, because they're not allowing me. Did I lose my solution? Bro. Bro, oh my god, bro. Oh, dude. Okay, so it's not loading. We'll end the stream here. We'll continue it later today and finish all of the easy playlist. You're thinking, oh, Fod, you're going to finish all of the easy playlist? You think you're that good? It's not that hard, especially when you get to like the bottom ones because they're not as important. But yeah, it looks like Leetcode's rate limiting me. See you guys. Stop streaming. Yeah.